Oh, I gotta go. All right, hey, I got somebody on the other line here. I gotta hang up. Okay, talk to you later. Bye. Hey, geometry, good to see you guys. Um, we're gonna do a lesson on what a rhombus is today and special properties of rhombi. Rhombi, gotta like that word, huh? Um, a rhombus, if you didn't remember, is a parallelogram. Or sorry, oh yeah, it's a parallelogram with all four sides congruent. So it doesn't have anything to do with like angles or things like that. It's just all four sides are congruent. So let me draw a quick a rhombus. I mean, ooh, that's a pretty terrible drawing. Maybe I should try that again. All right. Is that better? Oh, I have a hard time with that. Um, uh, third time's a charm. Let me get right in front so I can see. That's probably as close as I'm going to get. Um, okay, so all four of these sides are the same. Um, and then they go through and they give you a bunch of theorems about rhombi. And think about this. This is what I always get kind of amazed at is some of these are pretty, pretty intuitive. But, back in the days of Euclid and these guys, they had to come up with these things by basically trial and error and then prove that they were true. It's pretty amazing. So, 615. It says that if a parallelogram is a rhombus, then its diagonals are going to be perpendicular. If I draw that and that, these are going to be perpendicular. Okay? That's 615. 616 says the diagonals are always going to bisect the opposite angles. So down here, they're splitting this angle into two equal angles. Same here. I don't know that these two are going to be the same as those two though. But they're splitting these two into equal angles. Okay, what are we? 617 is just the converse of 615. It says that if you start here and you look and you see that these are perpendicular, then you know that this is a rhombus. Okay, that's 617. And 618 is the converse of this one. It says that if you have a diagonal that's splitting opposite angles, then this figure is a rhombus. Okay? All right. 619 is something a little different. So let me erase this and make this a little less messy. And I know that I'm going to draw a perfect one this time. Oh, yeah. Okay. 619 says that if this is the same as this, then you know this is a rhombus. So basically, if one pair of consecutive sides are congruent, then it's a rhombus. Or, I could have done this one and this one, or whatever. One pair of consecutive sides is all you need. That's 619. And then the last one has to do with the relationship between a rhombus and a rectangle and a square. So think about it for a second. Which one is the most general of those? If we were doing a Venn diagram, which one is the most, can you see that? Which one is the most general? Well, remember that A rhombus has 4 congruent sides. A rectangle has 4 congruent angles and opposite sides that are parallel and equal. And then a square has 4 sides that are equal, 4 angles that are equal, and they're parallel. So if you look here on page 461, they show you a little Venn diagram. So over here would be rhombi. They have 4 sides and they're all congruent, but it doesn't say anything about the angles. Over here would be rectangles. They've got 4 angles equal, opposite sides parallel, but you don't really know that the sides are the same. And then you have a special in here, you have a square. A square is both a rhombus and it's a rectangle. Does that make sense? It has properties of both things. So 620 is just a theorem that says if something is a rhombus and it's a rectangle, then it's a square. Okay. I think, honestly, that's all there is about rhombi. Now, there are a lot of theorems, and you can do a lot of proofs with these. I don't think any of them are super hard to understand, okay? All right, hope you guys have a great rest of your day. Go back to laying on the couch or reading a book or doing whatever you're doing. I got to get back to my phone call. Okay.